Hello folks, I am Ed Overstreet and I want to welcome you to the Night Sky Imaging YouTube channel where today I plan on processing Sh2-276 which is the Running Man Nebula that I took in January of this year. I just never got around to processing. I took it with a one-shot color camera and today I'll be using PixInsight to show a very basic and pretty elementary workflow in PixInsight from the weighted batch processing script to a final image. And I want to try to keep it simple. I can't promise you it'll be short. I haven't done a short video ever, and I understand the long videos are very unpopular, but I don't know how to do this any other way. So I'm I am what it is, as they say. So let's just head on over now and take a look at PixInsight, and we will get her going. All right, we're here, and the first thing that I'm going to do is I'm going to go to Process, and I'm going to come down to Process Icons, and I'm going to select Load Them, and I'm going to load my process icons. And if anybody wants a copy of this file, just message me and I'll send it to you. But these are the processes that I use over and over and over again. Not always with every image, but I want them handy because I use them often enough, and it takes a little bit of time to go up here to process and then go down looking for the process. And so this just makes it easy. And it also kind of is the sequence that I use when I am processing image from screen transfer function. Then I usually do a crop. I sometimes apply a linear fit when I'm doing narrowband or LRGB images, but not one-shot color. And these are the pixel math equations that I routinely use to combine narrowband images to different mapping patterns. How you combine RGB, LRGB, and just basically pixel math. Then dynamic background extraction or automatic background extraction, DBE edges. There's a special dynamic background extraction tool that I use for removing gradients, especially the multiplicative gradient that are optical train issues. We'll talk about that. Background neutralization, then I color calibrate, usually run histogram transformation if I'm not deconvolving an luminance image. And if I have magenta stars, I'll remove them. 2 programs to do that. I decide which one I'm going to use. Dealing with star size, this is all now in the nonlinear state, using curves, the clone step, and saturation, running local histogram equalization, ACDNR noise reduction, TVG the noise. Just about replace that with noise exterminator. We'll talk about that. Some sharpening using MMT, and I'm usually about done by that time. I may want to remove the stars and work on the image without the stars. We'll try probably doing a little bit that today too. So let's get started. I want to go to a script, batch processing, and the weighted batch processing script. And I've already ran this because it took about an hour to run it the first time. So I don't want to pause and wait that long for us to get started. But in order to add your data, you can select several different options. What you are going to be adding is bias, darks, flats, lights, and you add them down here by selecting bias. And then this image was taken on January the 25th. It's the Running Man, and I used a Vixen 625 millimeter refractor with an ASI533 one-shot color camera. So here are the folders that I've created. My lights, I have 2 lights, and the only reason why I have 2 lights is because I went through all of my lights and I deleted, or I moved all of the good files to Blink. I created a Blink folder. So what I'm going to do is show you how I do that by taking these files and moving them back to, actually I can't do that, I'm in PixInsight. Hang on a minute. Let's go to folder and Astral Drive 222 January the 25th. Let's go to our Blink files. Let's grab all of them. We'll blink through them again. It doesn't take long, and you need to do this before anything else you do, even before running the weighted batch processing script. And then I'm going to move these over to light. So right now there are no folders or no files in the Blink folder, and we have all of our files in the light frame, so as they were taken. So these are my calibration frames, my master bias, my master dark, and my master flat. Obviously, I've already used bias, darks, and flats in the past with this setup. And when I used it the first time, it created masters. And I use those masters over and over again for periods of time that make it appropriate. For example, in the summer, with the temps being relatively hot and humid every night, I have a set of darks. Then I delete those when I go into the fall and things start getting cooler. And I take another set of darks, and I take them at 15, 30, 45 seconds, 1 minute, 60 seconds, 90 seconds, 120, 240, 180, 240, 300, 360. And so that usually takes all night to take 20 darks each. And I just take one of the cloudy nights with no threat of rain to take those darks. I also managed to take bias, and I have not really seen a significant difference taking dark flats. So I've been using bias calibration files happily. But I take my flats much more often, and particularly because dust and stuff gets on your sensor, and so I take a set of flats weekly usually. But I'm going to use a master flat because just like 2 or 3 days before, I'd used the same kit with no changes, and I had a new set of flats with that, so I'm going to use the master from that imaging run. So let's get started. I mentioned Blink, so for the time being, let's close out of this. Let's go to Process, All Processes, and let's go down to Blink. And we want to load the folder down at the bottom. We want to load our lights, and we have 65. And here's our first one. It's done an automatic stretch so that we can see some data in the Running Man. You don't see much, but there is some. You also see some of the Orion Nebula creeping into the frame. So in order to stretch all of them, I'm going to use this automatic stretch histogram transformation to all of the image. So all of these will have the same degree of stretching. All right, And I'm going to play this like a video, and I'm going to change it to maybe a half a second for each image. And I want to make this a little bigger, and we need some room here. And so let's play. And it's going to click through. I'm looking at the image to see if I have any eyeball rejects. By the way, I'm still fighting a cold. I do this all summer. We had a transition or a meridian flip just then. I see a lot of hot pixels. So, and some modest dithering going on. Oop, there's a bad picture. And it's starting again. All right, let's stop it. Let's go back and let's examine these images closer. Let's just zoom into the running man, and I'm using the scroll wheel on my mouse to check these stars out, which really aren't all that round. And so let's go one at a time. And I'm looking at my stars to see if I'm... Oh, there's a hot pixel issue. I'm not sure exactly what that... Oh, another bad frame. So I'm going to uncheck this. I'm only going to keep the checked, and I'm going to uncheck the ones I don't want. I don't know what happened there. That's odd. Usually, if it's bad guiding, let's check this again. If it's bad guiding as a rule, let's go back. I'm just curious as to... Okay, what happened is I did a meridian flip. You can see that the Orion Nebula moved over here, and when it did and it started guiding, it probably started without it having enough settling time. So I have an issue with that one. So let's uncheck it. Hopefully the next one's okay. Yeah, it settled down, and so I was probably sound asleep when it flipped, or I would have seen that come in and marked it bad. And sequence generator. Oop. That one's a little not round, but we'll keep it. There's a hot pixel here. I'll go back and forth, and maybe you can't see it. Wow. Wow. I saw that earlier. I'm not sure what's going on there, but I don't like it. And it's not characteristic of any of the other. Looks like a Newtonian spider or half of one. So let's uncheck this one. And this one has some... Yeah, this one has some... Let's get rid of this one too. So we have 3 images that we're going to cull. And the way they don't make it easy in PixInsight to use this script, you would think you could just click on this and delete them, but I will select them all, and then I'm going to hold down the Command key on a Mac and our Control, and I'm going to select this one, and we got to go back up to the top and select this one. And the only ones we're going to keep are the checked ones. And I'm going to go down here to move, the move tools at the very bottom. It's next to the scissors. And I'm going to move. They're currently in the light folder. And I'm going to move them to the blink folder. And they're there, so we can close this out. All right. So now we're ready for the weighted batch processing script, and we're going to go up here to our scripts. And I understand by my streaming software, you can't see the very top row in my menu of my menus, but I'm clicking on script, and that opens up batch pre-processing, and we're going to go over and down to the weighted batch processing script. And as I mentioned, I've already opened my calibration files. So let's go get our lights first. And I'm going to, down at the bottom, I'm going to add the lights. And I have 3 lights in my light folder. And those are the bad ones. So we need to go to blink and grab those and open those. So here are our light frames. It shows no filter, but I used the L Pro filter by Optilong. I just didn't add it to the information that would have populated the FITS header. Okay. So there are our, we have, I think it's 65. So now we have 62 because we deleted 3. And I'm going to go over here to post calibration. That's 4 hours and 4 minutes on 61 frames at 240 seconds. All right. So that represents our light frames. Now, there are a number of ways that you can add your calibration files. If I didn't have masters, then let's say I wanted to add my bias frames, then I would have to go locate my bias frames in a folder, and let's do that. And here are my calibration files. I'll just pick any one, and I would load them, and that's what would end up being populated, 20 bias frames. But I have masters, and actually once you run the weighted batch processing script, after you've added the files, it will create a master. And I just copy the masters and I put them in one folder under Vixen 533, and I call it the calibration files, Vixen 533, and in it will be my darks from 15 seconds to 360. And once I run those, there'll be masters from 15 seconds to 360s. And so I have my masters along with my original files that were taken, and but it makes the weighted batch processing script run much faster if you can use the masters. It says it doesn't have to go through the calibration process with each of those calibration frames. So let's delete those because we're going to use masters. There's an easy way to do it. You can click on directory, and since I have, let's go now to January, and January the 25th. Since I have all of my calibration frames, my bias, my dark, and my flat in one directory, I can just click on that directory. And it tells me it's found them. And if I click on bias, dark, and flat, I see where it has my 5-second flat, my 240-second dark, and my master flat. So I'm going to clear that, and clear that. I'll show you another way you can add them. You can go to Files, and then you can go to your folder with your calibration files, and I can just, this is the calibration, I can just click all 3, and it brings them in. Let's clear that. But when you get started, and when I got started, I found myself just going through each one separately, finding it and loading it. So bias frame, and let's go back to my directory, and so I'm going to put the bias in the bias folder, darks, and the flat. Okay, so now I have my bias, my darks, my flats, my lights, and showed you 3 ways to add them. You can also create custom, particularly if your flats really are unnamed and you want to create a new name. You load what you have and you can change the name, image type. Let's suppose these are bias, darks, or flats, and the filter you might be using. So you can make some changes to your existing flats if they don't have enough information and you want to change things, and add the exposure time. So you can kind of custom make them. So we're not going to do that, but you can. Let's see, where am I? I want to go back to something though. And I want to go to this folder in January, and I want to show you this. You didn't see me do because I'd already done it. This is the folder where I loaded all of my lights. And originally all I had in this folder, when I first went to this folder, and the reason why I knew it was unprocessed is because there was one folder and all that was in it were lights. So I knew I hadn't ran it because there was no calibration frames. So what I do is I just right click and I create a new folder, and I added the calibration files. And then I went and found them and I put those in here. And then I create a folder called Blink because I knew I was going to run the Blink, and I was going to move only the good files to the Blink folder. And I create a file called 1-pix. And it's numbered 1-pix because I intend to run the weighted batch processing script only one time. But I have experimented and made changes to the script, and I've had 2-pix, 3-pix. It is just the name I chose, which will show the output of the weighted batch processing script. So when the script is over with, it's going to create all of these folders, and it's done, and it's already created all those folders. So this is what you're going to have once the weighted batch processing script is complete. So that's why these folders are in there. Originally all I had were lights. So I added my calibration files, I added the Blink folder, and then we ran the Blink process to move them, and then I created this this was empty at the time, and then when I completed my run of the weighted batch processing script, it populated it. And now here are my master reference file and my master color image that we're going to work on in a minute. So we're good to go. But there are some choices that you have to make here. Excuse me. Daggone. I want to do something so that we're all on the same page. I'm going to reset this. I'm going to reset all the parameters to the default values because that's what we're going to be using. And I'm going to clear all file lists. So we're starting from scratch. Now, your settings and my settings are going to be identical. These are the default settings. So I'm going to go to Directory, and I'm going to use the directory method. Just click on calibration files, and it's found them. And then I'm going to go to lights, and just redoing this again. We're going to Blink where my lights are, and we're going to open those. So now we have our bias, dark, flats, and light frames. So let's look at the bias options. Do not check overscan for your bias, and leave this to its default settings. Don't worry about anything here yet. We're going to go to our darks, and we're going to leave everything as is. The exposure tolerance, you're going to see that with your lights, exposure tolerance, and your darks. Let's say that, for example, I only had one set of dark frames that I had taken, and that was 300 second. Let's say I had a set of 500 second dark frames. But I chose that night to take some 300 second subs and some 180-second subs and some 240-second subs, and maybe some 150-second subs. Well, if I didn't have darks to go with each of those different exposure times used with the subs, I could do this. I could just take, let's see, I said 150-second subs. I could just put 150 seconds here, and what weighted batch processing script will do, it'll use the 300-second dark, and it will use that and apply that against all of my subs from 150, 180, 240 to the 300. So it allows you to get by with one set. Now, will it be a good run? Well, I doubt very seriously that the noise in my 150-second subs is going to be anywhere as near the noise in a 300-second, so it may create some issues. But there is a way of doing that. So would I want to do it? No. I want to have darks match subs, period. And so I just leave this as 0. The default is, I think, 10 seconds. Leave everything else the same. With flats, I leave everything alone. And with some exceptions, I will sometimes come back depending on how many, and this may be the case with this nebula, where you have large-scale pixel rejection. Lights, we do have some changes to make here. I check drizzle, generate drizzle data, because I pretty much drizzle everything. I don't check linear pattern subtraction because I don't have lines running up and down or crossways in my images. If you do, then you can select this and you can attach the rows, the columns, or if you've got a checkerboard looking image, columns and rows, and then you have to set a limit. This becomes trial and error. I can set this back to 0. I want subframe weighting checked, image registration checked, local normalization checked, and image registration. So normalization is a pretty neat tool that will find a reference image in all of your images, and it will normalize the rest of your images to that. It will like scale them and conform them to your reference image. So it's a pretty cool trick. It's different than your registration reference image. Much difference. We'll talk about that in a sec. I don't like the interactive mode, which will stop the weighted batch processing question and wait for your input. I just let it run automatically. And so I think we're good to go here. So let's head over to this tab where it says calibration at the top, and let's click on our lights. Here are our lights, our flats, our darks, and our bias. And we have 240-second light frames that will be calibrated with your 240-second darks, and the flats will be also used in this. The bias is subtracted from the flat frame, and that's what it's going to be used for, or your dark flat frame. All right, so while we've clicked on this, under calibration settings, since we have darks and the exposure matches the exposure on your master dark, I don't see a need to optimize my master dark. We're going to use darks and flats automatically. I do not use the literal value, I use automatic, and I apply it to all frames. I do use a cosmetic script, and it's right here. CC is what I call it. So I'm going to go ahead and load that process. I'm going to apply it to all frames. And you can see where cosmetic correction has been checked, that my auto pedestal output is automatic, and not literal. And I don't have optimized dark checked. And now we've got to check on, this is a one-shot color camera, and this is a big difference than if you were using RGB or narrowband image, filtered images, because you have to check this. And if your camera happens to record the barometric pattern to your FITS files, then it will automatically find it. If you leave it on auto, any ZWO camera won't do that, but all ZWO cameras use RGB. Leave the method to VNG and apply to all of your frames. You can look at your diagram for calibration. Okay, let's go back to master flat, and we're going to select the same on your lights, CFF images. We're going to scale these two. We're going to keep separate CFA scaling factors, and we're going to apply to all of our frames. And so we're good to go there. So we've debayered, and we look good to go. If not, you'll get errors here, and you'll get errors when you run diagnostic. Okay, next we've got to make a decision. If you want to have the best quality output, then select maximum quality with no compromises. If you want to run a faster script with suboptimal quality, you're more interested in running through this in fast, because this takes some time, then you might want to select a happy middle of the road option here. This is the fastest method of running. It doesn't run a normalization, and it cuts out some things, but it runs the script much faster, but it's at the sacrifice of image quality. So you pick one of these, and I'm going to select the obvious for me is just I want the best quality. I work hard to get the data. I don't want to screw stuff up by being impatient. I'll just walk away from this and let it run a little longer. I'm going to uncheck keyword groupings, because this is another video where you can add keywords to this particular photo shoot. And if you do this target again and you add those keywords, you can combine your data by searching and using these keywords. So it's a powerful program. Another video will address that. Under global options, and I prefer to use the global preferences, I select the first three. I'm going to let PixInsight pick my best reference frame for registration. It's just going to pick the best frame, whereas in normalization, it finds the best frame and then makes changes to your other image to conform to that. This just uses it for stacking purposes. And then we're going to have to create an output directory, and I do that in advance when I'm just setting stuff up, and it's called 1-pix. Now again, I've already ran this, so you see the folders it would have created. As a matter of fact, I'm going to go down here and I'm going to click create a new folder, and I'm going to pick that one, and we're going to go to diagnostic. See, down here it shows where I've picked 2-pix. I'm going to run diagnostics. It's telling me that I'm going to have 16.55 gigabytes of data, and I have available on that external hard drive 5638, so I'm good to go. And it tells me pretty much how much space my calibrated lights are going to take, and the cosmetic corrected lights, which are identical. So we're good. We passed the diagnostic test. Otherwise, there could have been errors there. So we click run, and we're going to continue. And so it's going to start running, and I'm going to stop this momentarily because there's no need to run it again and to have to wait for this. This will take a few seconds because I already have calibrated frames. So it should take less than a minute to, 16 seconds because I've already done it. I'm loading masters. Now, if you were using 20, 30, 40, 50 bias frames and 50 or 60 flat frames and 20 or 30 dark frames, this would take longer because they would be prepping these to be used in the calibration of your light frames. So I'm going to go ahead and cancel this. We've already made the run. And down here, click on abort. Okay, before I open my master, I want to show you this cosmetic correction script. And I suggest that everybody create one of these. The only thing you do is check this box and you select hot sigma and you slide this to 3. That's all you do. And then you open it up by going to, let me just close this out. You open this up by going to process, all process, and come down here to cosmetic correction. Then it's already set to that. And then you just save this process icon, give it a name. I call mine CC. Go to set identifier and just change it to a name, cosmetic correction. And then when you start running your weighted batch processing script, where it asks you, I'm going to delete this. I already have one. And weighted batch processing, we'll bring that back up. I'll show you where that is again. And we're going to load our calibration files again. Using directory. Fine, and we're going to load our lights, which are in the blink folder. There's only three images in the light folder, and we're going to go to calibration. We're going to click here, and where it says cosmetic correction template, I'll pull this down, and there's my saved process, and I'll click on that, and it will apply it to all of those frames. So that's how that's done. Now, everything else is going to go fast. That's probably the most, that one script is probably the thing that a lot of people struggle with, getting some output that they're happy with. So let's go to File, Open, and let's go to January 25th. We're already there, and there's our masters. So you're going to have two files. You're going to have the reference file that was used for normalization, and you're going to have this file. Let me stretch this a little bit. You have your reference file, but you want this one. And three images will come up. You have your rejection, high rejection, and if we bring up our screen transfer function, and I have this already saved in my processes, but you go to Process, All Processes, come down to Screen Transfer Function, and if you stretch this, you'll see some hot pixels and stuff that were removed, and they were rejected. So I don't know exactly where that was. I didn't see that when I blinked through them. And here's the dark. Often you can't see anything when you look through this other than color noise that was removed. That was rejected. And then here's my image. And be careful because these are linked. All of these channels, the red, the green, and the blue channel, are linked So you're probably going to see a green image. In order to stretch it, select this radioactive icon looking thing, and as expected, we have a green image. So let's unlink the R, G, and the B channel. The reason they were all stretched exactly the same, and so the dominant color just kind of overwhelms the other red and the blue colors. So what we need to do is unlink them and let PixInsight determine what is the optimum red, optimum green, and optimum blue stretching limits. And when we do that, we have an image much closer to what we were hoping we were going to have, I think. Let's see. We'll have to work with it. Okay, but take a look at the problems with this image. One, it was framed kind of bad, but I wanted to center the Running Man, which is right here, and in order to do that with this kit, I was going to get part of the Orion Nebula, which I'm going to crop out. And so, yeah, we've got vignetting in the corners. That's called multiplicative gradients. Those are multiplicative gradients, and they're easy to fix. The gradients that's caused by light pollution, those are called additive gradients, and they're not so easy to correct. But I don't see a need to even try, because I don't see a lot of gradient issues because of the sky. They're there, but they're not a problem that I may work with. I'll show you why. We'll try both ways. Okay, so we're going to start with the screen transfer function. Since I use this all the time, I'm going to take this triangle and I'm going to drag this. I'm going to right click and change the name to screen transfer function. Now I just called it STF and saved it. So what I'm going to do is create a set of icons for just basic processing. We're going to use some of mine, but we're going to save them as just basic processing steps. And I'll show you what I think everybody should be doing. I'm not an authority on this. I just know that if I'm going to use these over and over again, why not have them loaded each time I start working on an image, so I have them very handy and in the order that I usually matches my workflow. So the first thing I want to do is I want to rotate this image, because the Running Man is going from south to north. So let's go up to Process, All Processes, and I happen to know it's in the Geometry folder. Let's just go to Geometry, and it's called Fast Rotation. Or you can go to All Processes and go down here to I had it all process. That's why I hate this, because you lose it and it's just aggravating. Fast rotation. All right. So what we're going to do, since we use this all the time and we don't want to go hunt for it, we're going to save this, and we're going to call this fast rotation. And I want to move this over here. Now, if I like saving mine over here on the right, but I'm going to build two sets of these, one for you and the ones that I've been using. So what we're going to do now, and let me show you what this does. I can delete this now, and the next time I want to run fast rotation, I just click on my icon, and there it is. So I want to rotate this counterclockwise 90 degrees. So I drag the process and drop it, and there we are. So I don't need it. I've deleted it, but it's still here if I wanted to bring it up and do it again. So if I close out screen transfer function and I want to use it again, there it is. Okay. Now, the next thing we're going to need to do is to crop this image, because I don't want this nebula infringing on my target. And so I'm going to get rid of that. And that's really, and I'm going to reframe this. So let's see how we're going to do that. Let's go up to Process, All Processes, and let's find Dynamic Crop. And yes, since we're going to use this over and over again, let's save this as a process icon to be used again. And we're going to call this DYN, Dynamic Crop, and we'll put it over here. I want to reset it, and then I'm going to drag. I'm going to go down here at the bottom, and I'm going to wait till I've been able to grab it, and I'm going to move that up to about right there. And I hate losing these pixels, but, and then I'm going to drag this down to about there. And we're going to come in a little on the sides, just because of stacking artifacts. And let's see what that looks like. Let's move this up just a little bit. And so we're going to go to Execute. And that's what we got. So let's delete this. And the next thing I plan to do is to deal with this vignetting in the corner. So I would go to Process, All Process, and we're going to go down to Dynamic Background Extraction right here. And since we're going to use it all the time, let's go ahead and save this. And we'll change this to and Dynamic Background Extraction. Now, I have made a lot of changes, and there's a particular process that I borrowed from Sean Nielsen and copied it from Sean Nielsen. It's a method that he uses some of the time, and I like to use it some of the time as well. And so I make some changes in this, and you click down here to reset. And so what I'm going to do is just bring up my process icon. We've already saved it, and I call mine Edges, DBE Edges, and here it is right here. And so these are the settings that I use. And tolerance of 2.0, assistant relaxation to 6, shadows relaxation to 6, smoothing factor remains, I think, the same. The default radius is 114. I think I'm going to change this to 100 on this one. Samples per row are 10, and the weight that I'm giving them are 0.75. Now, if you think you've got some light pollution gradients in your image, and you want to try to fix that, then you would use division. But if you are dealing, which is my case, I'm dealing with these vignetting issues in the corners, then you want to use subtraction, because this is a multiplicative issue, not an additive issue. So I want to subtract this out that's happening in the corners. Also, when doing a nebula, I hate to run gradients that might affect some of the nebulosity. So I'm not going to use the gradient division correction algorithm. I'm just going to use subtraction. And I'm going to click Execute. I'm going to close this out. And I'm going to restretch it. So we're going to need to bring up our screen transfer function. And let's stretch it. I'll just leave that open. And So we removed some of them, but not enough of them. So I'm going to come back to DBE edges, and under subtraction, I'm going to execute it again. Some more, I got rid of some more. I'm going to execute it again. And I think that did it. So I have pretty much eliminated the vignetting in the corners. And I chose, because of the nebulosity that you're seeing all around here, I've chosen to leave the additive removal algorithm of division. I decided to leave that as is. But if you have a galaxy, a small galaxy in the center and not a lot of nebulosity, or it's a star field that has some gradients from light pollution, that's a good way to even out and flatten the field. Okay, now there was a time, and this is for my friend Ed, the Comet Hunter down in Anderson, South Carolina, because until just recently, I would use the multilinear transform for noise reduction while I was in the linear mode, because it's an outstanding noise reduction tool. But ever since that the new noise reduction algorithm by Russ Kroman was introduced, it's highly touted, and I recommend using that. So Noise Exterminator, I have it now down here, Noise Exterminator, and so you can create an icon, change the name to whatever you want, and save that. But first, you're going to have to buy it. And you can try it on a trial basis, but if you'll go to this website right here by Russell Kroman, then you can download and try the Noise Exterminator and the Star Exterminator. I'm using this now over StarNet 2 almost all the time because it does an unbelievable job of removing the stars from your nebula. For Photoshop, there's a gradient exterminator, and in Photoshop you can also shrink your star size if necessary by using and downloading these. But Russell's pretty much devoting a lot of his time to improving these products, and they're being updated all the time, and man, I highly recommend them. They're just awesome. Also, there's some other scripts that I recommend, and this is at the skypixels.net website, and they're by Hartmut Bornemann, and scripts I think you should consider having for running deconvolution. PSI image is good because this will create automatically for you a point spread function that you can use without having to manually select stars and apply it that way. I also recommend the game script right here. This is a masking script. It has nothing to do with games, but it allows you to create selective masks to use, and I'll be using those from time to time, probably not with this image. And let's see, those two are extremely important, and these are free. You just click on them, download them, and here are the instructions in a PDF file right here on how to load them into PixInsight. Also some visuals on how you manage your repositories in PixInsight, where they are, and how you manage them, how you check for updates, and so forth. So I recommend purchasing Noise Exterminator and Star Exterminator, and let's take a look at this. First, it's recommended that you run background neutralization before you run the Noise Exterminator. If you try running Noise Exterminator and you get some funky results, then try running it the second time, and on the second time run your background neutralization. So let's make a clone of this. First, let's just call this, let me delete it. Let's call this RGB, give it a new name, RGB, and we've ran a fast rotation. We have applied a crop. We have ran dynamic background extraction, and now that's it. So let's run the background neutralization, and what we want to do is we want to find some of the background, sky background, that doesn't have any stars in it, and background neutralization, there's my icon, but just go to process, all process, background neutralization, and here we go. The settings are the settings that you'll use that come up by default. So we have to create a preview, and you can do that by going to preview, new preview, or you can use up here on these menus, you can select this box right here, and you can draw your preview window. So that looks to be like a pretty clean part of the background. So I'm going to run background neutralization. Just drag this over. Forgot to do something. Can't run it. I've got to click on this box and select this background. Get in a hurry. So select this background preview. Now run it, and it's going to apply that background to the rest. You can see the change. So we're going to delete this, and this X right here, red X in this box, will delete the preview, or you can go up to preview and delete. So we've ran, and it's restretch. We have ran the background neutralization. So now let's go down to noise exterminator, and keep in mind this is a linear image. It has not been stretched. So if I reset it, it's dark, and so we have to click on the radioactive Houdini in order to see an image to work on. So we're going to take the noise exterminator. It comes up at a default of 90 with detail at 0.15. Is linear. This image is still linear. It has not been stretched, at which time it will be nonlinear. So what we're going to do is we're going to select the right AI, artificial intelligence, and the last one happens to be this one. They're updated from time to time, so I have the right one, and so let's apply it. It's going to take a second. Okay, it actually took 30 seconds, and so let's take a look. And that's some pretty impressive noise reduction and you don't have to do a mask either. So we have tackled noise and using Russell Croman's noise exterminator. So we've also created our icon over here, and we're going to change our name identifier to, the reason why I like to continue to change the name of my file, this is a personal preference, is that when I come back and revisit this, maybe a year later, I want to know kind of what I did. And so I can tell pretty much what processes were ran, and maybe a new process comes out I want to add. All right. I'm going to make a copy of this, and I'm going to start saving. These are the major changes I've made in the linear stage. And right now, I'm going to color calibrate this image. Excuse me. And there's several ways that we can do this, but I'm going to use photometric calibration, and that's this icon right here. And I'm going to close this out. You can go by process, all processes, and come down here to photometric calibration and open it up. But I have some settings that I have changed, not much, but some. So I want to close this out. I'm going to open mine up, and we'll save this process icon for you. And we're going to call this set identifier color calibration photometric. And we'll put that over here. And what I'm going to do is I want to acquire the focal length, the pixel size. I want all the information in the FITS header, the RA and the deck, so that what this is going to do, this is going to run information that it gathers from my FITS header. If we go up to File, FITS header, then this information in this file right here is going to populate this photometric calibration process, with one exception. ZWO cameras do not write a lot of the important information, we talked about that earlier, into the FITS header. And also, I have made some changes to this, and some of that has been overwritten. So what I'm going to do is I'm going to go to File, Open, and I'm going to pull up the Blink folder, and I'm going to just grab just any one of those light frames. And I'm going to use this light frame right here, and I'm going to acquire, because this light frame does have the RA information, the declination, the focal length, and the pixel size. So I'm going to click on Acquire, and it has found everything. And so it's been changed. Now, another way you can do this is you can go to Search Coordinates, and you can type in Sh2-276, and you can search from a database. You can pick several different databases to search from, and it's found it, and you can get it. And so it has a little different orientation, but there's the right ascension there. So I'm going to go ahead and use mine, because mine is absolutely on target. So here are the RA deck. This is a 625 focal length, and I don't need this anymore. I just needed it to load the right information, because it's been overwritten as I've processed this. And so let's go ahead and I've cropped this a good bit. Let's see if it'll run. It's going to take a second. Okay, it's finished doing its thing, and we're going to stretch it again. And so this is the photometric calibration. Now, what happened is that this process uses both astrometry and it uses photometry. Astrometry is a form of plate solving, so it went out on the internet and took the information that I had, and it searched a database so that it could plate solve this image. And then photometry is taking the correct colors from the database and using color balance to apply those to my image. So if you want to get as accurate as you can to what the colors of these stars really truly are, then this is the program that does it the best, and I love it. So we're going to close this out. There are other ways to run color calibration that's much simpler without the settings. You can go to Color Calibration, and if you go back and click out let's create a new background image. I'm not going to run this again. I'm just going to show you how it can be done. We were over here. Okay, let's say this is our background, and then we need a white star. That's a gold star. I know we got some white stars that aren't blown out. That's a green star. Let's see if this is blown out. Let's click on this. Okay, let's click a new. I don't like that either. That's the problem. You got to find a white kind of star. All right, let's try here. And then we want to unclick structure because this isn't a globular cluster with lots of a big heavy star field, but we want a reference image for our white, and so that's preview number 2. That's preview 2, and we want a reference for our dark, and that's preview number 1. And then what you do is you just drag this on here and it will color calibrate it. I don't want to double do this, so I'm not going to use that. So let's remove those previews. And here's where we are so far, and it's time now to stretch this image. We're going to stretch this image 2 ways. I'm going to make a copy. First, I'm going to change this to photometric calibration, and I'm going to drag this. Actually, I'm going to make 3 copies, and I'm going to save this one here. We don't need that. And let's just minimize this one first. There are some new scripts in PixInsight that work exceptionally well. And one of them is a script called, it's in the Easy Processing Suite, and you've got to download that. And it's called the Easy Soft Stretch. And so let's run it. And it gives you a picture of what it's going to look like after it's stretched, and I like it. So there we are. We have stretched the image and using the easy script, easy soft script. So we're going to change this name to easy stretch, and okay, and let's bring this one down, and let's use what I've always used. Let's use the histogram transformation. So I'm going to bring up the histogram transformation tool. You can do that by going to Process, All Process, and coming down here to the histogram transformation tool, which is right here. And we definitely want to save this and put that over here and change that to, so we got a I'm anal about arranging these like in an order. Okay, we want to find our image, which is the clone, and it says clone right here, and we load that image. Then we're going to unstretch this. We're going to stretch it again and drag this. We're going to drag this process onto this bar right here, and you can see what it did. And so we'll unstretch it again, and we'll drop this over here, And now we've stretched this using the histogram transformation tool. Looks pretty good. So here's the stretch using the easy stretch, and here's a stretch using the histogram transformation. And all it did was chose to move the sliders a little bit differently automatically. So it's all about preference. What do you like? So I'm going to save that, and I'm going to put this on histogram transformation, and we'll make a copy, and I'm going to put that over here, and I'm going to change this name to nonlinear. And so I'll keep a copy of that over here. I'm going to save this as a project when I'm done, and all of these icons and all of these steps will be saved. And I can load the project and come back and work on it at a later date. Okay, that's looking pretty good, and I would like to bring out some of the red, some of the detail here. And so in order for me to do that, I think I'm going to need to, by the way, the screen transfer function, don't use it. Or if you use it sparingly. There's too many other ways you can use to remove color, but when you remove green from your image, you move all of the green from your image. And so that isn't the real world. That isn't what's really going on up there. But it's a tool you can use, but use it sparingly or not at all, is my opinion. It's been I'm kind of a follower of Adam Block and Warren Keller and Ron Beecher and Peter Prolla, and I agree with them. It took some convincing. We can try some curves, and we'll create by entering this here, clicking on this circle, a preview. So any changes we make are just non-destructive. We're not affecting the image at all, just the preview, but we can kind of look and see what's going on. So I'm going to go over here with saturation, and I'm going to click right here, and I'm going to look at my curve while I click, because right there is where I really want to affect that saturation. So I'm going to put an anchor point, and I'm just going to kind of drag this up some. And so what you can see is, I'm going to click this off and on, you can see that I've affected the red just right here. And it's also not just right here, but that was where I was trying to concentrate. Reds all over were affected as well, don't get me wrong. But I didn't mask anything away. But this was where I was targeting color-wise. Okay, let's let's reset this. I only want one. I only want one curve. If you want to see multiple curves, then you can select here, but I only want to see one curve at a time right now. So I'm going to create an S curve and add some contrast. I'm going to add a modest amount to the brights, and the darks, I'm going to drag it down a little, not much, too much. And even bring the mid-tone up a little bit, because I want some of that nebulosity. And we're going to apply that. That's enough of that. We're going to probably use curves again. Okay. I'm not going to work on the stars Yes, I might. Let's take Star Exterminator, and I don't see any need to run Noise Exterminator again. It's almost a little too plastic light for me now. But let's go to saturation slider one more time. Again, we haven't used this, but let's go to the saturation slider. Let me save this process. By the way, I didn't save the curves process, and we need to do that because we use this over and over again. So we got curves. We do. So we'll just call this curve. And we've got saturation. And so let's just close this up. Let's bring this over here and curves, because we're going to use, these are just basic processes you're going to use every time. So I would suggest you save them. I still have some vignetting in the corners, but you do your DBE. When you're in your linear state, not when you're in nonlinear. So we'll approach that a little differently in a minute. So let's bring up, I was telling you about the game script. Let's go get the game script. I'm going to go up to Script, Utilities, Game. Game is one of Hartman-Boardman's scripts. And it's a mask creator. And I'm going to use a ellipsis, and I'm going to click Add, and there it is. And I'm just going to protect, I'm going to make a mask around my nebula right here. That's all. And by the way, I want to show you how this is used. I doubt very seriously I would do this in this image, but I want to show you what crosses my mind. So I'm going to click OK, bottom left. And now I have this mask with the gradient. I'm going to drag the mask over to this bar and drop it. And then I have to save my mask. It's my game mask. And I'm going to save this as game mask. So I'm protecting this nebula. But what I want to do is to provide, I want to make some changes to everything but the nebula. So I'm going to go up to mask, and I'm going to invert it. So now the mask is protected, and everything else is subject to any changes I make. I really don't want to see the mask. I'm going to go back to mask and uncheck show mask. So let's bring up your curves over here, and let's look at a real-time preview. And we want to take the RBT, all the RBT channels, and let's just reset this, and let's drag them down. And what you're going to see is that the corners are going to darken some. But the mask isn't. I mean, the protected area isn't. So I'm kind of getting rid of a little of that gradient at the expense, though, of some of that nebulosity. So find what you want. All right, let's click that. And so we have our mask still attached. You can tell because of the, it's red. When the mask is gone, then it's not. You can tell it's gone. I want to just remove the mask, and so we're back to normal. But let's add the mask again. Just drop it on the bar. When you move it over here and you see that box by the cursor, drop it, and then your mask is applied. This time, let's show the mask, and let's invert it again. No, let's work on the mask. Just don't show it. So now we're going to work on the mask. Let's bring up curves. Let's bring up saturation. We were going to do that a while ago. And we only want to saturate the mask area, not these other stars. This would be better done with a star mask. So let's click on red. And this color is, where is this color showing up? It's on the far right. You see that line on the far right? So what we're going to do is we're going to kind of drag that up some and saturate that just a little more without affecting the background, only the nebula. And do we have some blue in here? Yeah, see where I'm clicking right here and you see where the blue is. So let's drag some of that up. And we're bringing out some of the blues. So let's apply that. All right. And we can remove the mask. And then let's go down here to MMT sharpening, multimedium transformation. You can find that by going up here to your process, all process, multimedium transform right here, and this tool comes up. And so in order to, you want to choose these settings, and you do that by, say, click on this, and under the parameters bias, I've got it set to 50. You see this number 50? If I check on this, this is 100. If I check on this, this is 100. But you can change this to whatever you want, but I want it at 100. As a matter of fact, I'm going to uncheck this. I'm going to go to 0 here and just uncheck that altogether. So I don't have anything here. I'm just going to apply to these different layers. And I don't have a linear mask. Let's see a real-time preview and see what that's going to look like. This is kind of a sharpening, not a fine sharpening, but let's look at before, after. That's good. So that's good, like it. So you want to save this one, and it's MMT. And if it's too sharp, you can dial these down. As a matter of fact, let's bring this back up to my default, which was 50. And let's see what effect that would have had. I'll open this window again. And let's click on and off. I can just leave it the way we got it. All right. I hope these changes show up when you see them. And we can delete our preview. The only other thing we're going to do is just, I want to show you how you can, is using this star exterminator. I'm going to generate a star image, and I want to select unscreen the stars. This is not linear, this is a non-linear. So I want to show you how well this star exterminator performs. Drag it and let it run. Okay, it's pretty cool. Let's drag this icon. And we'll put the MMT up here. Star exterminator. Close it. So we've pulled the stars out of the image, and this is the nebula. I kind of wish I hadn't darkened it. There was a lot of nebulosity that I've lost while trying to deal with what was left of the multiplicative gradients in the corner. That's okay. This is about the Running Man anyway. But then there's our stars, and you can work on this image without the stars and then combine the stars back, and that's what I generally do. Or work on the stars and I've got a lot of the stars with halos and some of the colors I know aren't really right. They've gotten affected by applying saturation and curves. So let's just suppose that I bring up saturation, and let me click on one of these stars, and can you see it's in the green area? You can see the window, and it's kind of a green. So what I want to do is I want to drop the saturation. Let me get a real-time preview. I want to drop the saturation down a little bit, and maybe a lot bit, and because this kind of has a green cast to it, and also we've got some reds showing up about right there. And let's drop the saturation of those down some. Let's apply that. Let's apply it again. All right, that fixed it. So now we've gotten rid of the green, and now what we have is more of a blue in our stars, and that's kind of what I wanted. And some of the red stars, or the almost turned brown, are look much better. So I'm just going to call this stars, and I'm now going to change the name of this to Running Man. All right, let's put them back together. I'm going to go up here and click on Pixel Math, and we're going to create an icon, and we're going to call this set identifier Pix Math, and we're going to put that over here, but you can find it by going to Process, All Processes, and Pixel Math. And the first thing we're going to do is select use single RGB expression for this, and let's bring up our editor. Here are all of our images, and so we want Running Man, and we want to take the Running Man images and we want to add that. So I'm going to hit the plus key, stars, and I might not want 100% of the stars. I may opt to do only, let's say, 0.90% times the stars. So I'm going to take the Running Man image, and I'm going to apply 90% of the star's value luminosity. So let's close that, and let's open up. I want to create a new image. I don't want to replace any of these. I want to create a new image, and I want it to be the same as the target, but I'm just going to go ahead and use RGB, and let's just drop it on either one. And so here we are. Let's minimize stars and put that over here. And I don't like it. And let's Running Man, and let's put that over here. But what I don't like is how it really screwed up the stars in this image. So that's ridiculous. It looks fine up here. No, it doesn't. So that we're not using, so we're going to delete that. I'm going to keep the nebula just because I may work with it. The stars, they look fine, but the way it added them back, I'd have to play around with pixel math to get them to add them back right. But I don't have the right combination in that math equation. So we're going to go back to nonlinear. There's our, no, we don't want the nonlinear. Let's get rid of this here real quick. Let's go back to nonlinear, and let's go ahead and stretch this again. Actually, let's see, make a clone. Let's save that, and we're going to let's apply MLT to it, and we already know those work. A little sharpness to our stars, and I like it. It's good. And let's also take our saturation from our, let's go over here and use saturation. And we're going to click on right here. And that's going to be about right there. And we're going to bring that up. Let's get a real-time preview. Bring some of that saturation up. Some of the blues, which are right here. We're going to bring those up. That's too much. I did last time. All right. Let's go for that. Let's close that out. Guys, I'm just kind of liking this the way it is. I don't know what else. I can put the game mask back on it like I did before and invert it. Mask, invert, so that we're just working on the background. We don't need to see the mask, so let's don't show it. And let's bring up curves. I'll click on curves over there. And let's just dumb this down some. Actually, the mask needs to be inverted. Nope. Do we have, hang on a second. Do we have the, yeah, we got the game mask on. So, and we want the mask. We're going to have to see what it looks like. So the background's protected. We want to invert that. The mask is protected. And so now let's bring up our real-time preview and let's lower down or dumb down some of the, not much. All right, apply that. Too much there. And get rid of our real-time preview, get rid of our mask. And that's probably about where I'm going to stop in that neighborhood. Might get by with one more run of noise reduction, but I'm okay with the way it looks there. Now, the last thing I'm going to do is move these, is probably save this file, save as, and I'm going to go to we're going to the 25th, and I'll just go to the root directory, and I wanted to give it a name and I got too fast. Let's go again. Save as. And we're going to call this Running Man. Give it any name you want. And we want this to be a TIFF file. And in case we want to work on it in Photoshop, we'll make it a 16-bit unassigned integer. And so we're going to save it. So the file's been saved, but all of this hasn't been. And these are the new processes that I've created that I would suggest you use at a minimum somewhere. Put them somewhere. I'm going to keep mine, but start them over here and add to them as you become more comfortable with other processes that you'll use routinely. No point in adding the ones that you won't be, but the ones that you do use a lot, and that's what I would do. All right, then I would go up to File, Save Project, and I would find the folder where this image is located, and it's the right folder because there's the Running Man TIFF, and I would give it a name, Running Man Project, or Sh2-276, and then save that, and it will save it as a project. And the next time you load this image, everything you see here will come up. The picture, all of these icons, process icons, and all these steps, images with the various steps will all be loaded. And if you wanted just to save these process icons, you'd go to Process, Process Icons, Save Process Icons, and the only thing you'd be saving were the processes. And so I already have mine saved. I don't want to do it again. I don't want to include those. I'd be duplicating it. And that's it, folks. The only other thing I could think to say to you is have a great rest of the day. God bless, stay healthy, and see you on the next video, and clear skies.